This chapter we will discuss about the sinusoidal, the steady state analysis. This is the first chapter to describe the electric circuit in the domain of frequency domain. Later, we will discuss the electric circuit with only the frequency domain. Before that, chapter 10 of one fixed frequency is discussed in the electric circuit. So we call the one fixed frequency electric circuit source, we call the sinusoidal the circuit. The sinusoidal means the sine wave form or cosine wave form of the old current and voltage. Especially we will discuss about the steady state, not the transient. Later we will discuss about the transient state with the sinusoidal the source. So in this chapter, we will discuss about several topics here. What is sinusoidal source? That means we have only one fixed frequency sinusoidal source. So because the frequency of the source is fixed, the all current and voltage in the circuit is fixed, the same frequency. So we can see the characteristic of the circuit in only according to the one fixed frequency. So if later, when you say we can see the electric circuit in the frequency domain, that means we discuss about the voltage and current as a function of frequency. So in the case, the frequency is not fixed. The frequency is a kind of the variable to describe the system. And after that, we will discuss about the phasor. Phasor is a new concept to describe the system, especially all the variables of voltage or current is a sinusoidal. Then you can use the phasor. It's very simple. And I will introduce the impedance. Impedance is a very important concept to that. Actually, in the time domain, in the circuit theory first, there are three the passive element, R, N, L, C. But in the viewpoint of the frequency, R and C is the same passive component. I mean, actually, it's not same. Like R and L and C, there it has their own characteristic. So it's a different element. But in the time domain, we see that is R, this is L, this is C. We see that the element is different. We need to express the R and C independently. But in the frequency domain, R, L, C can be expressed is one continuously. The analogous, the continuous variable, that is the impedance. We'll discuss about later. And to check the characteristic of impedance, the series impedance and parallel impedance will be analysis. And in the viewpoint of the phasor concepts, we can analyze the voltage in electric circuit. And to do that, we need some more useful tools, kind of the approach method. As we studied in the time domain, there was the mesh equation or node equation. The same concept of mesh equation and node equation can be applied in the viewpoint of the phasor. So in the same way, you can use the Thevenin or Norton equivalent circuit, and we can also use superpositions. And more, we can describe the electric circuit is graphically. We call this a phasor diagram. And also op-amp can be introduced in the sinusoidal the component. So and also we can get a complete response about one fixed the sinusoidal the source. So we will discuss in these topics in this chapter. It's quite a long story, but I will explain step by step. So what is a sinusoidal circuit? I mean, because when the source is connected to a kind of electric circuit here, then we call the step input means the voltage or current can be varies in this stepwise manner. So we call that is a step input. In that case, the output is a function of these inputs, and that is consists of two things: the transient response and steady state response. So transient response means the input is changing in this step here. Because of that, output will be shifted state from the here to there. Output is defined in this input, and output will be defined as this input. We call this input response, and this response we call that is a steady state response. But as the input is changing this way here, the same way output should be changed from the here and here. During the change of the input, output will be varying. I need to be moved up to from this state and this state. And there are many. In this transient, there are many patterns to move this state and this state. If output here, for example, output here and output here, this is caused by that inputs. This is caused by that input. The output will be shifted from the here. Then if shifted in this way, we call this is underdamp, or this move like critical damp, and move like this way, we call it overdamp. We discuss about it in the timeline here. But when you say the source is a sinusoidal input like that, that means the frequency is fixed and the amplitude is fixed. Then the output has only sinusoidal output. In that case, if the sinusoidal input's frequency, maybe there will be 10 hertz. I will call you discuss about what is hertz. But anyway, if the source has a 10 hertz source, then output frequency should be 10 hertz. But the magnitude, this magnitude and phase will be different. But the frequency is the same. We call that is a sinusoidal, the steady state output. That is a very critical problem in here. If input is 10 hertz, output should 10 hertz. Input is 100 hertz, then the output should be 100 hertz. So if input has a 110 hertz and also 100 hertz, then output should have 10 hertz and 100 hertz. So that is the sinusoidal circuit's characteristic here. I want to give a simple explanation of how to solve the sinusoidal ET circuit. So it's a very simple way is sinusoidal variables transform to the complex number. And in the complex numbers, then we can use the new variable is a phasor and the impedance. So electric circuit can be analysis with phasor and the impedance. Then there is a very simple and easy to describe the steady state response of sinusoidal AC system. So in this chapter, we will discuss about what is a phasor and what is an impedance relator. Anyway. And the sinusoidal circuit has a very good characteristic like that. If source input is a sinusoidal, then output will be sinusoidal. And the source frequency, this is a very important sentence here. Source frequency determines the frequency of all voltage and current in the circuit. So source frequency, the frequency 10 Hz, then all variable voltage and current is a 10 Hz variable. So sinusoidal current, we call this as alternating current, it's AC current we call. So sinusoidal circuit can be called as an AC circuit. We will discuss here. The sinusoidal circuit means the AC circuit. So I will introduce about the sinusoidal functions. then some terminology will be introduced newly. The first period, the frequency, and the angular frequency we'll discuss about here. Actually, sinusoidal function is a periodic function. In Korean, this is a 주기 함수. What's the meaning of that? That means this is sinusoidal functions. Then from here to here, this is one period. And next period, this waveform is exactly the same with next waveform. Then we call this is a periodic function. Then relatively the pattern, this pattern is repeated. Then this time period of one pattern we call this is a period. In Korean is 주기. So example, if we call this is maybe the period is, for example, 0.5 second. Then this is 4 second. Then this will be the quarter over here. So this length is 0.1 second. That means this is time, this is 0, this is time. Then that value is functions of 0.1. I mean that value will be f t equal to 0.1. And this is exactly the same of this point here. What is that? This length is 0.1, but this period is 0.4. So that will be exactly the same with t 0.4 plus 0.1. That means f t equal t0 plus t equal f t equal t0. So this is a characteristic of the periodic function. And for example, if this time, actually one period is 0.1 seconds, that means for 1 second, this pattern will be repeated in 10 times. We call this is a frequency. In Korean, 주파수. Frequency f means 1 over period. Because this is 1 over 0.1 is 10. That means for 1 second, 10 times the same pattern is repeated. So the unit of the frequency is hertz. So f is 1 over period. Then another terminology is angular frequency. In Korean, 각 주파수. That means, for example, in the viewpoint of this wave, we call this sine wave. That means this is a 1 period. That means sine 2 pi is a 1 period. So in the viewpoint of the sine wave, for 1 period, this angle, theta, is started from 0 to 2 pi. This is 1 cycle. So in the viewpoint of here, if frequency is f is 10. That means for 1 second, and the angle value of this theta is changed from the 0.2 pi is 10 times. So the 2 pi. So angular frequency means is frequency multiplied by 2 pi. This order is radian per second. Why? The frequency is, the unit is hertz, is the same with 1/2 second. So this is radian per second. This is angular frequency. This is very important things here. So we call this as a T is period. The F is the frequency. This is 1/t, and the angular frequency is a 2 pi f is omega. Is a unit over here is radian per second. Hertz is 1/second. So here I will introduce a new things and new terminology here. Pager. I will introduce these things at first here. This is T, and there are one here and here. There one sine wave here. Looks like that. Then we call this waveform is sine omega t. That means for example, if omega is 2 pi, so what's the meaning over here? Then t is 0, then sine omega t is sine 0. And t is 1 second, and no, 0.25. That means sine 2 pi 1/4 is sine pi over 2. That means here. And t equals 0.5. That means sine 2 pi 0.5 is sine pi. That means here. So when you say the omega is 2 pi, means when t is 1 second, that will be here. If the omega is 2 pi, then that means when t is 0, then the point will be here. So anyway, it's not important here. If there are another waveform here, this is exactly the same with sine omega t is packed. There's some delay here. That means this waveform is sine omega t minus ta. Actually, this is not TA. Actually, this is a kind of theta. It is theta. Sorry. But theta is this length here. So this happens at TA. So theta will be same with omega TA. Then this is 2 pi divided by the t, TA. It means 2 pi t, TA. This is a theta. We call this is a pace in Korean 위상. So this is an example here. For example, there are V is A sine omega t. Then with t plus t0 means A sine omega t plus t0. So they will be written in this way here. So this we call, this is pace. Not pager, this is pace in Korean 위상. So dimension of pager is a radian. So if there are Vt here, then there are some Vt plus Ta, and this is a Ta, then that will be a, if we say this is a one period here, this is T, and this is a Ta, then the pace is the value of it is 2 pi Ta divided by the period T. And this is important here. The example here, if V is 10 sine 2 pi and 10t, that means omega, this is omega, this is angular frequency is 2 pi 10. What's the meaning of here? That means because hertz is, frequency is 10 hertz. That means one period is 0.1 second here. So if we express this waveform in not time domain, but the phase domain, then this can be written here. Expressed here and here. It is 2 pi here. So angular frequency is 2 pi 10 is 20 pi radian per second is our angular frequency. The frequency is 10 hertz. Therefore, the period is 0.1 second. Then this is example. Consider the Vt is 10 cosine 200t plus 45 degree volt, and V2 is 8 sine 200t plus 15 degree. Then we need to know the determine the time by which V2 is advanced or delayed with respect to the V1. You can say it like that here. At first, we need to think about what is the angular frequency. Angular frequency omega is that values 200 radian per second. But this is a cosine and this is a sine. Then we need to think of, make a simple in the identically express the sine or cosine. In generally, we'll express all sinusoidal variable as cosine. So I transfer the V2. V2 is 8 sine 200t plus 15 degree. We change here. How can do that? Sine theta is the same way cosine theta minus 90 degree. Right? You can use this idiom. So 8, instead of sine, we use cosine and use that exactly. 200t plus 15 minus 90 degree. So that will be 8 cosine 200t minus 75 degree. And how about the V1? V1 is 10 cosine 200t plus 45 degree. So here, the theta 2 is minus 75. Theta 1 is 45. So what's the meaning of here? Then what's the meaning of here? Because omega is 200 radian per second, so what's the frequency? Frequency is 200 by 2 pi values. So anyway, we can change that this is kind of the theta. Then when t equal to 0, then that will be 0 because cosine 45. So there's a 10 if this is a 45. So this is minus 45, the peak values, and this is a 45, then there will be like that. This is a waveform of V1. This is a V1. And how about the V2? V2, when this is t equal to 0, that means this is minus 75. That means this is minus 75 here. So $45, maybe 90, and this is 75. So there will be peak values here. So there will be something like that. This is a V2. So what is the value of here? Is theta 2 minus theta 1 is minus 75 degree minus 45. So there will be minus 12 degree. So we can change this. That is 2 pi over 3 radian. Then theta 2 minus theta 1 is kind of 2 pi TDT. Therefore, time delay TD is theta 2 minus theta 1 T and 2 pi. That value is that values minus that values. So minus 2 pi over 3 and this is 2 pi. What's T? There's a frequency here. So T equal 1 over frequency. So that will be 2 pi divided by 200. So 2 pi 200. Then that value will be minus 0.0105 second. You can calculate it like this way. But as you see, if you see that the voltage and voltage values in the time domain is very complicated. What is advanced? What is the delayed? No, this is very complicated. So I want to introduce a new concept, new idea of the phasors. So in the sinusoidal functions, if we deal with the sinusoidal function in the time domain, the result is very complicated. So we cannot catch a point, very difficult. So I want to introduce a new concept of phasor. We call it in Korean, in some books, phasor, in some books, phasor. So I don't like to say this phasor. If there are sinusoidal voltage and sinusoidal current, for example, voltage is sinusoidal, then Vt is A sine omega t plus etc. And there are three unknown parameters in here. What's that? Magnitude, and phasor, and frequency. So, but we know that if there are one frequency source, then all variable of voltage and current have the same frequency. So if we know the frequency, then we don't need to calculate the frequency anymore because frequency is fixed. So all voltage and current is a common frequency with the own frequency of source. Then we need to consider only two variables. What's that? Magnitude and phasor. So we want to deal with the variables with only two variables, the magnitude of phase. So we call the phasor is a complex number that is used to represent the amplitude and phasor angle of the sinusoidal. So this is phasor is kind of a complex number in Korean, 복소수. But this A cosine omega t theta can be expressed with only magnitude A and the angle of theta. So we call that is a phasor. So when you do that, the time domains, the function should be cosine, not sine. This is a promise. I mean, there's a fair promise. So that means because we only choose the magnitude and the phase, so that variable can be expressed in the polar coordinate system. The expression with the magnitude and the phase. This is a phasor. So for example, if current is a 120 cosine 400 t plus 6 degree, the milliampere, then I will want to express that this variable is phasor. Phasor, when I say phasor, we use the capital variables, I1, and anymore, this is not t variable because we ignore the t. We use omega. Then 100, and phasor is 60 degree, and the unit is milliampere. And also I2 is this is not a function of time. This is omega, the frequency domain. It is magnitude is 100. Actually, no, this is sine. We should sine theta is the same in cosine theta minus 90 degrees. So we can transport that value over here. 100 cosine 400t minus 75 minus 90. So that will be 100 cosine 400t minus the values. So I2 omega is magnitude is 100. The phasor is minus 165 degree. That is the phasor of I2. This is the phasor of I1. So what's the meaning of the phasor? A phasor is a kind of the polar or polar representation. In the representation in the polar coordinate system. So there are one vectors here. Then this, if the magnitude of this is A, then this angle from the real axis is theta. Then this vector can be represented with magnitude and angle is over here. This is kind of a complex number. But in this variable can be expressed in the rectangular coordinate system. Then that will be the real values and there will be the imaginary values. So that if that value is A and that value is B, then that V can be expressed as A plus JB. So A theta is the same with A plus JB, but the representation is different. This is represented in the polar coordinate system, and this is represented in the rectangular coordinate system. The same vectors, but name is different based on the coordinate system. So this A values is a real value here. This is a magnitude of VA. This is angle theta. So A is A cos theta. And imaginary value B is A sine theta. So that is the same expression over here. So A value is A cosine theta and B is A sine theta. So the magnitude over here, from here, we can calculate. So A and B, A is A cosine theta, B is A sine theta. But in the viewpoint here, A is root A square plus B square. And theta is kind of arctangent over here. Arctangent, this is A B over A. But when the theta is positive, I mean in the right angle domain, this is right, but the angle is here, then this is wrong. In that case, we make 180 degree minus that value over here. So phasor can be expressed with the polar coordinate system or the rectangular coordinate system. So for example, if there one phasor, is V1 is 4.25 115 degree, and V2 is minus 4 plus 3. So convert V1 to rectangular form and V2 in polar form. So we can make it simple. So this is rectangle, the polar form. We can change it here. This is 4 point. What's the meaning of that? The magnitude is 4.25 and angle is 5 degree. So that can be written here. How can do that? 425 cosine plus J 425 sine 105. So that will be minus 1.796 plus J 3.852. So in the same way, what is the meaning over here? This is minus 4 and plus 3. That is a V2. That is a V2. And you can express this term is the magnitude over here is magnitude over here A is root 4 square, 3 square is 5. The problem is angle, but it looks like this plane. So theta is 180 minus arctangent, because this is a minus with 4, 3. So there will be 143 degree. So we can express that will be 143 degree. So what's so when you V1 expressed in the time domain, then what's better over here? And maybe V1t will be 4.25 cosine omega t plus 105 degree. I don't know what is the value of omega. But anyway, because omega is not given, I don't know exactly what is omega, but if V1 can be expressed in time domain, it looks like here. Actually, V2 is 5 cosine omega t plus 1 4 3 degree. And we find the time domain here. So when you convert to the time domain, the polar form is more useful. But when you express in the rectangular plane, the complex plane, and sometimes the rectangular form is more useful. So anyway, I'm here want to tell you is Poisson is a value of complex number. So because in the sinusoidal variables in the electric circuit, in the viewpoint, in the time domain, it's very complicated and very difficult to deal with that. So we have an idea that if the source frequency is fixed, then all variables in the circuits, in the voltage and current, has the same frequency. That means when we analyze the electric circuit, we don't need to care about the frequency. Why? Frequency is fixed. So we have three variables, the magnitude and frequency and phasor. But because frequency is fixed, we don't care about frequency anymore. Then we want to express all variables of voltage and current with only two variables. That is a magnitude and the phase. So to do that, we have used one new concept, is a phasor. Phasor is a kind of a complex number to express the sinusoidal variables, the magnitude and the phase. So that is a phasor. So actually after that, we will calculate the voltage and current with the phasor. So phasor is a complex number. We need to know how to calculate the complex number. So phasor calculation is very exactly same with complex number. For example, V1 and V2 is a phasor. That means the complex number. So it can be expressed in the polar forms like that, or rectangular form like that. Then the adding law is very simple. When you add two different the complex number, then how to that? Then the real term is adding each other, and the imaginary term is adding each other. So to add, what is better useful? This is a polar form, and instead of polar form, the rectangular form is very useful when you add in the complex number. But when you multiply over the divisions, then this is useful in not rectangular form, but the polar form. So when you multiply two different complex number, then if you express this polar form, then magnitude and multiplied and phasor is added in this way. If you divide the complex number, the magnitude is divided and the magnitude is minus. But you can do that with the polar numbers. Not polar variables. You can use the rectangular variables. If V1 is A1 plus J I can use the small variables here. A1 plus JB1 and V2 is 8 plus JB2. Then V1 and V2 is A1 plus B1 and 8 plus JB2. Here, we can do that here, like that. So A1, A2 plus J, A1, B2 plus J, B1, A2 minus B1, B2 will be A1, A2 minus B1, B2 plus J, A1, B2 plus A2, B1. This is exactly, it's okay. It's the same things. But well, if there will be E1 Ch10-1 V2 Ch10-2, then same calculation V1 V2 is E1 Ch10-1 E2 Ch10-2, and there will be the magnitude multiplied by magnitude, and the phasor is adding. Yeah, this is more simple. Another thing is conjugate. Conjugate is conjugate means the real has the same sign, but the imaginary sign is different. So when you express the conjugate in the polar form, then theta is different. I mean, this is V1. So when you conjugate this V1, that means imaginary B1 is minus. In the viewpoint of polar form, that means theta1 is minus theta1. So polar form is E1. The page is sign is different. Then the last page identification. I mean, when you say the V1 is V2 is the same, that means V1 is a real term and the V2 is a real term should be same, and at the same time imaginary value should be same. When you say like that, then the phasor, the V1 and V2 is the same. In the viewpoint in the polar forms, when V1 is V2 is same, that means magnitude of V1 and V2 is same. At the same time, the pace V1 and V2 should be same. Then you can say two vectors, I mean two complex number is the same. The example here, the V1 is the rectangular form is like that, and this is the polar form, and V2 is the rectangular form is that, and the polar form is that. Then determine the V1 and plus and V2. So it's very simple. If we use the adding, then what is better useful? The rectangular form is useful. So V1 plus V2 is V1 is minus 1.796 plus J 3.852 plus V2 is minus 4 plus J 3. Then the result will be here and here minus 5.796 plus J 6.852. And what is the multiplication? V1 and V2. This polar form is very useful. This is 4, 2, 5, 1, and 5, and the 5, 1, 4, 3. So that will be multiply here is 21, and pager is 1 and 5 plus 1, 4, 3 is 21. Actually 2, 5 way. That will be same with 21 minus 102. So division is the same. The V1 divided by V2 is 4, 2, 5, 1, and 5, and the 5, 1, 4, 3. So there will be 4.255 and 1 and 5 minus 1, 4, 3. That will be 0.85 minus 28 theory.